Hey, it's me, Ben, and welcome to my dorm room. Naturally, I forgot my tripod, so I propped up my camera against the microwave, and we'll see how this goes. So I've made it. I'm now officially at Georgia Tech, all moved into my dorm room, and I'm going to start showing you guys some cool projects that I'm going to be working on here. But before we do that, I want to sort of wrap up a video that I've been wanting to make for a while about my electric bike that I brought with me to Georgia Tech. So this video is going to be about how I built the battery pack for my electric bike. Then there's going to be a follow-up video for going over how I built the electric bike itself, what I purchased, what I think about it, and a demonstration of me riding the bike. Just for reference, this is what the battery pack looks like now that it's done. Definitely not something I would take with me in airport security, but it's wrapped up well. It's got 2 layers of foam, a layer of IKEA cutting board, and duct tape to cover it. It's got a big XT90 connector for discharge. See if you can see that. And an XT60 connector for charging. And it works great. I've tested it out and I've gotten 27 miles out of it. And it only brought the battery down to about 55% charge. So I'm theorizing probably around the 45 to 50 mile range is the maximum distance for this pack. It's all using reclaimed 18650 cells, and it's able to get me up to a top speed of about 33-34 miles per hour. So I'm really proud of this creation, especially since it uses recycled laptop cells, and I'm especially pleased I didn't blow it up or blow my house up. So anyway, sit back, watch the show, and I'll see you later. I'm currently in the process of creating the units to equalize the parallel battery connections. As per this quick little schematic here, we're going to have 8 18650 battery cells in parallel and connected on the positive side with series resistance in order to equalize the voltage charge. So these are the 1K resistors that I'm going to use right here in the diagram, and then 8 18650 cells are going to go in here, and then they're going to be equalized in parallel so that when I connect the tabbing, the battery tabbing to the cells, there's not a huge current flow, and we don't end up having problems with those cells. So now I have the entire arrangement of 112 18650s sorted by most capacity over here, down the line, all the way until you get to least capacity down here. And my plan is I'm going to input all of these values into an Excel sheet, figure out what the average is for the cell, multiply by 8 in order to figure out what the average capacity of a parallel bank will be, and then I'll create, I'll get a rough estimate of that. I'll get pretty close by taking 1, 2, 3, 4, 5, 6, 7, 8, and putting one of these top cells into each of the others, each of the packs, and then the next 8, each one of those goes into a pack, and so on and so forth down the line, sort of trying to equally distribute, and then I'll add up each of the packs and manually shuffle some batteries around to balance the values. So as you can see here, what I've done is I've sorted all 112 batteries into 14 packs of 8. And I wrote down the milliamp hours for each pack, and right now each pack is clocking in at around 16,100. The goal was 16,101 milliamp hours, and the range, so the highest minus the lowest, is only 35 milliamp hours, which is actually really good for a pack like this. So the next step is to put all 8 cells into these devices that I've made right here. And what they are is they're basically just all of the negative terminals put together, connected together right here. And then all of the positive terminals have 1K resistors in between them so that the voltages of the batteries will be able to equalize over time. So that when I spot weld the nickel strip to the cells, there isn't a huge current flow and it doesn't get hot. Alright, I'm going to pop the batteries in and I'll see you then. So right now I'm assembling the battery pack. This is a sort of a sticker sheet, and it has little rings, concentric rings and circles, and you basically peel off the the outer ring and you stick them to the top of the battery. And what that does is when you go to spot weld the nickel strip on top, it prevents the nickel strip from, if it ever gets banged against this lip, from potentially shorting out the positive and negative of the battery. So this is what the batteries look like now that they're done equalizing, and you can see that they're basically each set of equalized batteries is going to go into the pack, and it's going to be built up like this, and then spot welded together. So right here I've got the spot welding set up. I just decided to spring for the Sunco 709A. It's alright. It could be better, but the welds are pretty decent. It appears to be doing the job just fine. And so I've cut some pure nickel strip, and I'm using that on the pack. And it goes on like so. And sort of try to center it on right there. And then I'll start from this end, and this is the set of probes they give you, and down there's the foot switch. So I'll press my probes on here like so, and then just fire. And I like to do about 3 or 4 per battery terminal, and it looks like that. And then just continue down the line. So we'll do the next one here again on camera. So you can see that I like to actually use not that much pressure, because if you use too much pressure, there's not enough resistance, and the weld doesn't actually come out very good. So just like that, and you're all set. So I'm going to repeat that for all the parallel strings, and then I'll start doing series connections. Alright, and now the entire bottom side of the pack is done. The welds look pretty good. I've done multiple welds, a minimum of 4 spots per cell, but some of them are 6 and even 8 on some of the negative sides, really just to make sure that we've got good connection there. And so these are all the parallel connections. And what's going to happen afterwards is I'm going to flip the pack over and do the parallel connections on the bottom side, which is really going to be the top side. But then what will happen is down here on the bottom will come some series connections, and with those I'm going to do many buses over on the series so that the high current can pass through it, because each of these parallel connections only needs to supply the power of one cell. Whereas each series connection is going to need to pass the entire current load of the battery through it. So that means multiple bus bars jumpering across it, perhaps one on each 8 cells, but I don't think so. I'm thinking maybe 6, and then leave 2 open here in the middle maybe, or maybe leave the ends open and do all the center ones. Either way, it'll be very redundant, and then I'm going to make sure to jumper some of these right here, just so that we can have some of these welds right here carry some of the series current as well, instead of just trying to weld over top of what we've got. Alright, I have finished all of the parallel connections for the cells, except for the end here, which will be the positive terminal of the battery, and over here will be the negative terminal of the battery. And the negative will be routed around and down and into this little pocket here where we're going to put the BMS and other wiring and so forth. The next step is for me to wire it in series. The current, or the voltage, is going to stack. So now, as you can see here, all the parallel connections are in place. They've all been spot welded down. And what's next is the series connections. So in this battery, the electrons flow into the positive side, and they'll end up going through all the batteries in series like this, and come out the negative side, go through the load, and then back into the positive. And so we need to facilitate the series connections, and it's the series connections which are going to carry most of the current. And in order to do that, we're going to put some of the nickel strip down across like that, and we're going to spot weld them in place. And I'm not sure right now, but I'm going to go look up the specs of this nickel strip and double check it. I think I'm going to need 6 of them per series connection, so that'll leave 2 slots open. Maybe I'll leave the 2 end slots open or something. Anyway, in order to cut these the right size, I just put a piece of tape down on the table, which is the length the proper length of the strip, and then I'll keep unrolling nickel strip and cutting it, and make a bunch of those and start spot welding that in place. Alright, as you can see, more progress has been made on the battery pack. I have all the series connections done right here, and I've added an additional soldered on series connection. There's 3 of the nickel, there's actually 6 nickel strips per series connection, but then I also soldered this on just in case, because, you know, the spot welds are not perfect, and if anything were to happen, I wanted something a little bit more stable. And so up here you can see my BMS, and the BMS is just as wide as the pack, and it's going to sit up here with enough room for wiring to be tucked in under here, just like that. And this is the balance connector right here, which is not plugged in, it's just inserted a bit. And this is all the balance leads that are going to go on this side of the pack, and these are all the balance leads that are going to go on this side of the pack. So what's next for me to do is to hot glue and zip tie the BMS to the pack, and start getting these wires connected. This goes straight to the negative. This is a discharge connector. This goes out to the e-bike. This is the charging connector. This is the charging wire. This goes to the charging connector. And then to hook up all these balance leads, and that should be it for this pack. So I'm going to start working on the balance leads and getting this BMS secured. So right now you can see I'm in the process of putting down the layers of foam, and these layers of foam are going to provide padding on the battery. I took the e-bike out for a test today using this battery, and it works great. The battery didn't get hot at all, so I'm not worried about the insulating properties of this foam causing overheating of the battery pack. It shouldn't be an issue. If anything, this foam will help insulate the battery pack from the hot outside temperatures. Anyway, so I'm going to finish hot gluing the foam in place, and then start working on putting the semi-hard outer case on. So for those of you that stuck around to the end, you can see here my cable that I built using 2 XT90 connectors, 2 female XT90 connectors, and I'll also give you a quick dorm tour. So this is what it looks like on the inside. The couch right here, a couch cover is going to happen, my vanity and clothes over here, and my desk, minus the open drawer right there, and bed up there, and that's the general setup. So it's actually quite roomy. Also, for the range that you get, which is anywhere from 45 to 50 miles, the battery only weighs about 11 pounds, so easily able to pick it up with one hand. And so in terms of wattage, watt hours to weight ratio, this battery clocks in pretty well, like other lithium-ion batteries. If you want to stay up to date with the projects that I'm going to be doing here at Georgia Tech, don't forget to subscribe, like this video, and don't forget to ring the notification bell, because apparently YouTube will not give you a notification that I posted a new video if you don't do that. Anyway, thanks for watching, and bye.